All right, guys, welcome back to the Michael and Rob show. I'm Michael. No, wait, I'm Rob. He's Michael. And welcome back to a part two of a one-part series on photo eyes. And so last time we talked about what is a photo eye, types of photo eyes, mounting, and wiring. And this time we're going to get it kicked off with operation. And so um, I'll turn it over to Michael, but essentially there's two types of common operation, light on and dark on. And Michael, what's your preference and why would you choose one over the other? I know we have a standard here.
Light on all day.
Light on?
Yeah.
Okay. I too am a light on fan, but I'll tell you this. It was a hard lesson to learn, and you actually made me do it when you used to work for CHC and we were a subcontractor and you came onto our job site and you said, what kind of idiot put these dark on photo eyes in here? And I said, we're that idiot and dark on is the way to go, right? So can you explain the difference?
So really they're referencing the output state of the sensor as it pertains to seeing its own light. So in a light operate photo eye, the light is emitted, as we discussed before, from the emitter, and that light bounces off of the reflector. Once it bounces off the reflector, it comes back to the receiver. If it sees its own light, it gives the output. Right? So as long as it's seeing the reflector, so if you had this wired to a PLC right now and the reflector was lined up properly, the signal would be high. You would have the positive signal going to your PLC input.
On a light on.
On a light on.
Yep.
On a dark on, the signal would not be sent unless you blocked the photo eye, right? But, we were talking a moment ago about the brackets, like getting hit by a forklift, right?
Mm-hmm.
Well, even though they're robust to get hit by a forklift, that could cause them to misalign.
Yep.
If those photo eyes were dark operate photo eyes, you would never know it was misaligned because you're not expecting a signal anyway, right? So
right.
When you're talking about in the PLC, we almost all of our eyes in our standard AOIs are able to detect a jam, right? So if a eye is blocked for an inordinate amount of time, so longer than we think it should be, we call that a jam. We can stop the flow of conveyor. We can indicate on our HMI. We can even go so far as to turn on a buzzer beacon or send a text message to somebody when a product is jammed. Well, that's really only possible with a dark op photo eye, because if it was never giving us a signal, we then couldn't determine that the reason why it's not giving us a signal is because it's misaligned versus it is aligned, there's just nothing in front of it. Whereas with dark or light operate, we can detect that it's not looking at the sensor. Sure. Or even the wire getting severed. If you were to unplug a light operated switch, you would lose your signal the same as if it's blocked. And then programmatically,
sure,
the conveyor would accidentally shut down instead of accidentally continuing to run.
Right. And so the industry I'm from, we would call that fail safe.
Yep.
And that's just it, is if the reflector gets out of alignment, we can detect that. If the wire gets cut, we can detect that also, because we're assuming a package is there. And one, if it's an excess amount of time, it's going to show up as a jam. And two, well, if we assume a box is present, we're going to really do what we were supposed to do in the first place, which is count it, start a timer, like a lane full. And I like that because at the worst case, we think there's a jam and we shut conveyors down. The next best case is that we think it's a lane full and we shut conveyors down. Or, we think there's a package there and we try to release it, but there's no package there. And so that's much better than a dark on sensor where if the wire gets cut or the reflector gets knocked out of alignment, you never make any decisions. You never will detect a lane full. You'll never detect a jam. The boxes could be 18 feet high, piling up, and you just wouldn't detect a jam because we would never get the signal back.
And even in the PLC for dark op, if we move the reflector, we could detect that change in state. But the real issue becomes that cable's cut, it's unplugged, those types of things, right? That becomes a real issue. You end up dumping a conveyor lane into a sawtooth merge, and people are calling our service line.
Right, and so let me have a shout out to the programming boys and girls. The reason that we hate the light on is because it forces you to use the normally closed contacts, and it's counterintuitive. You want to read your logic, if this, then and that, and so you have normally open, normally open, normally open. Then you have a closed set of contacts for that light on, and it's just counterintuitive. Now, I will say it's easy once you've done it for a while, but right out of the gate, we cussed you a lot when we came back here after that time, and I'm like, he just doesn't. It's just so much. It's not difficult. It's just a pain in the tuchus to have to train your brain, or retrain your brain rather, to look at that one set of normally closed and realize that it 100% of the time it works backwards. It works just like a normally open set because we're expecting the signal and nothing happens.
Yep. But I dealt with the same thing. But I just remember, being a service technician and going in, conveyors releasing, and oh man, it's unplugged. So that was a good lesson.
So let's move on to common uses of photo eyes, and I want to preface this entire category we're going to talk about with a photo eye is really used to do one thing. At least in our industry, it's used for product detection, right? And whether or not it's supposed to be there or it's not supposed to be there, it's really detecting product. And so some of the common uses are to detect jams. Hey, a package is here for longer than X amount of seconds, generally 5, and it shouldn't be, right? And by that I mean the conveyor's running, so the package should be moving by. And so that is a caveat that I want to take into consideration. Just because a photo eye sees a package for 10 seconds doesn't necessarily mean it's a jam.
Absolutely.
Right? The conveyor couldn't be running. And then laneful conditions where the conveyor's not running and the package is still there for 10 seconds or 5 seconds. So therefore your accumulated conveyor is full upstream or downstream from there, and we need to stop feeding that conveyor itself. Looking at that right now and detecting, can you talk a little bit? We skipped over on mounting, but now's a good time for uses. Like, let's talk jam, lane full, and present or clear. I see there that your photo eye is skewed some amount of degrees, and actually you have 2 photo eyes there, and one of them is straight. So can you touch on that for a minute?
Absolutely. So this is a typical application for a sorter. A sorter is a conveyor that can take a single flow of product and deposit it into multiple locations. Because the sorter has a mechanical mechanism in it that kicks the product off the conveyor. Although that's not the point of this conversation, I think it's critical to kind of talk about that operation a little bit because it kind of lends to the reasoning as to why we have these sensors in these 2 locations specifically.
Can you draw me a box on there and kind of show me the flow?
Yep, absolutely.
As it's coming down and what's happening, because I want to go over, like, why are those 2 photo eyes perpendicular to the conveyor, but that third one downstream of the takeaway lane, he's actually skewed some, and why is that, and when should we use that?
Yeah, absolutely. So if product was coming down this conveyor, it's critical for us to be able to detect the position of the leading edge of these cartons. Actually, I should say it properly, leading edge of these totes, and that's going to lend into why we have the angled eyes. So as product is being conveyed down this conveyor, if you look at the green box, it will hit the leading edge of that photo eye. And then there's some other kind of what I call controls magic going on in the background where we're able to sense the distance that belt has traveled with an encoder. And right at this decision point right here, we're going to update the leading edge of that package, and then we will have a positional offset to this divert position if you look at the first box shown here.
Sure.
Once that box gets to that location, it's actually going to divert off of the conveyor, right? So it's going to go this way. The reason that second photo eye is there is right as the trailing edge passes this photo eye, we know it's safe to drop this divert back to the lower position in time for this carton or case to then pass that point. It's kind of hard to tell in this drawing, but these divert mechanisms work by lifting up. So it lifts the box off of the belt that's letting it move from north to south in this drawing and allows it to be pushed from east to west. So this photo eye here is used for two reasons in our sorters. One is to train our sorters. Because this is one long continuous belt here, and we're tracking position of that belt, during startup and commissioning, our commissioning agents are able to put it into a startup mode. And at that point, they will run a single box down the conveyor and automatically set all of the divert positions. So those photo eyes are used for that, as well as updating the position of the box in case any type of slippage happens. The second photo eye you see here is our divert confirmation eye. It's confirming the divert actually happened. We call that a positive divert because even though we've lifted up to divert that off and we ran the motor to tell it to run off, those things may not have happened for other reasons. You know, there could be a problem with the pneumatic system. There could be a problem with
it didn't actually lift.
It didn't actually lift, right? Or it lifted, it went to get off, but for some reason, something was hanging off the bottom of that carton and it didn't come off. So this photo eye, as I mentioned before, is also being used as a jam eye. So not only is it confirming that the package got all the way up the sorter, but if it's blocked for too much time, which we're able to calculate, we know that it takes X amount of time to pass that photo eye, we will be able to detect the jam and stop the entire sorter. So that was a little bit long-winded, but both of these sensors at each divert are used for the positional tracking as well as the positive confirmation that that carton, case, or tote actually got off of the sorter.
Okay.
The second photo eye you see here is our lane full eye. This conveyor that is shown here is gravity conveyor, meaning that it doesn't have a power source that's telling the rollers to turn. Yeah. Gravity is actually causing the product to move. So that conveyor is actually on a downward angle. The reason it's angled is because we have totes on this system. And
the same could apply for boxes too, right?
Yep, the same could apply for boxes as well. But I will show you kind of an example of some of the engineering we go through to determine the angle of that. All right, guys, appreciate your patience. I actually went and grabbed the drawing offline there so you didn't have to watch me muddle through CAD work. But I wanted to bring this up to show you why photo eye rotation is critical. If you look at the photo eye on this down lane, as I said, we're running totes. Well, most totes in the conveyor system are tapered. The reason they're tapered is that way you can nest totes together. So if any of you guys have been in the warehouse, you'll notice that there'll be a stack of totes. They're able to stack because they are tapered. The downside to tapered totes, as shown here, is when those totes are butted together, say touching at the top, there is actually a void at the bottom of those totes. Because of that, if we were to have that photo eye looking straight across, say just like this, there's a chance that at this elevation, say 2 or 3 inches off the rollers of the conveyors, that would see right through, it would see the reflector, and we would never be able to detect the fact that
so you wouldn't detect the lane full.
Yep.
And that would tell our PLC, I'm open for business, send me more product. And I want to make a note. You wouldn't think it, but that happens more often than not. If you put that photo eye straight across there, 7 times out of 10, the lane will be full, and it's just going to happen to shoot through that void. That tells the PLC I'm good to receive, and we send that product off, and it's a mechanical transition. And so what I mean by that is if you have that lane full of product, we're going to raise that belt up, and it's going to smash that one tote or box into another on the takeaway lane. But then even worst case, that has nowhere to go, and now that box or tote has not cleared that transition eye. So when we see a falling edge of that eye on the down lane, we know to take that transfer, the pop-up transfer that's up, motoring the box off, we know to lower it back down. And so what's happening is that's not happening. And so we have the ability to run product that's on the sorter going 300 plus feet per minute into that transfer. Then you have an end over end smack. That is a disaster. I mean,
Absolutely.
it would be fun to watch, but it's a disaster because you have the ability to ruin product. You're going to build it's going to be a pile up. It's going to be,
It's fun to watch if somebody else did the controls.
We're going to get walked off the job like you don't know what you're doing. And so it's critical, absolutely critical, that you skew eyes when you must. But also, I want to point out something else up here. First off, I want to say it works for boxes too. I don't care if it's a tote and it's tapered. If it is a lane full or if it's not position critical, skew the eye. Okay, but I also want to say, let's go zoom in on that filter regulator there. We just put 2 more packages. I know we're dealing with totes, talking totes, but what I have here is I had Michael add 2 packages here. One is narrow, one is wide, and I want to show you why it's so critical that the tracking eye is exactly perpendicular. So go ahead for a minute and skew that thing to like 20 to 30 degrees, that photo eye. So on a sorter, the other way. That doesn't really matter, but yeah, that's good. On a sorter, we track that thing by the inch, okay? And we absolutely must have that precision to engage shoes on a shoe sorter, engage the pop-up on a right angle transfer, which is what this is, engage a pop-up on a 22 degree or 30 degree. But what's happening here is, can you show the leading edge of that box you just moved on that photo eye? Yeah.
Trailing edge.
So what's that? There.
Trailing
and so you're doing trailing edge, and that's fine, but look at the difference, right? Can you actually snap a measurement from one of those to the other one? How far offset are they?
A little over 4, almost 5 inches.
Okay, so 5 inches. We're gonna if you had that photo eye skewed the same number of degrees it is right now, and you had one narrow package and one, and let me tell you, that is not even an extreme. On a conveyor that can take things from 6 inches wide to 24 inches wide, right here we're not even at that much of an extreme, and we're 6 inches out of our tracking on this conveyor. And yeah, shoe sorters won't have a tracking eye, but we do a ton of sorters that do use tracking and update eyes, and it's practically necessary to have that. And we would be 5 inches out of our tracking, and I can tell you right now, the sorter will not work 5 inches out on tracking. And so that photo eye is an example of where perpendicular is a must. And the takeaway eyes, so the one eye there on the bottom left hand that we know the package is fully on the takeaway lane, that must be perpendicular too, or else you would have the same issue, but this time it would be the length of package that affected it, because when you are right angle transfer, and that's the worst. Right angle transfer is the biggest abuser of that. If you had that photo eye skewed, milliseconds count when you're transferring off and you have to drop that transfer bed. And so if you had a short package that was going off onto the side and its falling edge hit there, it's going to be a lot different than if you had a long package which trailing edge fell somewhere else. And so we're talking about, an extra second or two. When you have a 6 inch gap, and I realize a 6 inch gap is probably not practical for a right angle transfer, but just bear with me. We don't want any more time than we have to have for that right angle transfer to be popped up and risk a misgapped package coming behind it to accidentally run into that pop-up. It's just going to create a mess of things. It's going to, people are going to be picking stuff up off the ground. And so it's critical that you actually know,
you're absolutely
why
right.
is this photo eye here? What's it doing? and doesn't need to be skewed or perpendicular because both are mission critical. And again, I'm going to plug Pendant. The bracket design we have is awesome. If, let's say, accidentally every photo eye was mounted perpendicular, you can just adjust this knuckle and you can get, I think, like 6 inches of positive 3 inches of positive leading, 3 inches of negative trailing, and you can create a 6-inch skew, which brings me to my next point. If you want to bring up our skew calculator to help the people look at this and say, yeah. So bring up the skew calculator we have right now. It's in Excel. Awesome tool. I don't know how I've lived without it this long. But essentially, Michael, if you want to go over what it does.
Yep, absolutely. So I'm going to actually get rid of our camera for a second here and just bring up just these two objects. So it's historically in the field we would play with these angles, and Rob, you actually helped me with the kind of fine-tune this with some of the math, so I appreciate that, but I will go through it. So quite often we've calculated the gap we need on a system. So we have another gap calculator that tells us how far these products need to be away from each other from a upstream, downstream standpoint to make it so when this first product pops up and is diverting off, you got to keep in mind the whole time that's happening, these are still moving in a downward position, right? So we know what that gap's going to be. So utilizing this calculator, we can input the program, the gap that we've calculated. Let's say we need a 18-inch gap for that type of sorter, and we can put the maximum package width, let's say it's a 12-inch package, and we put the conveyor width at, say, 24 inches. It's going to tell us the offset of the reflector. So from the photo eye location to the reflector mounting position, this is extreme, right? We have a really narrow package and a wide conveyor. It would tell us that needs to be greater than a 38-inch difference. So a more standard application would be just like this, a 15-inch package on a 24-inch wide conveyor or 22-inch BF.
Right. And so you would want to take the 2 minimum width packages. That's the worst case, right?
Yep.
The worst case is if you had a very minimum width package. And so I also think, the gap does take into consideration. But here, we're looking at totes. Zoom in on here, right? So let's just do a tote application real quick.
Mm-hmm.
And so that's what this is, right? It gives a good example of that tote application. When the totes are butted together, which they would be in a low pressure accumulation application, we measured that as a 5-inch gap at the lowest point of that. And, that's where sometimes your photo eye height comes into consideration because, let's be honest, if you knew all of your totes were 12 inches to the top and you can see that the top is touching, you could technically get away without skew, but that's really that's really the lazy way to do it. And so here, if the totes are touching 2 inches above the bottom of the bed, we have a 5-inch gap, right?
Mm-hmm.
And so the conveyor width we'd want to say is 22 inches wide, or in this case, it's 20. Let's do 24 inches wide, and those totes are 15 inches wide. Also, so we need something greater than 10 inches of offset, and I understand that is 18.5 degree angle, but nobody measures that, and so it's I wonder if we don't need to detail that on our drawing for installers.
Yeah, so we are
we show them skewed, but how does the person know if that's 10 inches? Because I can tell you our brackets probably won't go from perpendicular, switching them back and forth to 10 inches of skew.
Absolutely. So as you know, on some of our standard drawings, we actually show kind of the standard offset, which is the 6-8 inches. But to your point, when we get into some of these taller tapered totes that can vary, the engineering team does put thought into that, and adding it to the drawing is definitely a fantastic idea.
Well, I wonder.
I want to point out something though while you're thinking. Another kind of critical measurement here is this 26 inches. One might think, well, it doesn't. Why do we need to know what is going on here? But remember earlier we talked about some of these sensing distances, right? So when we look at the sensing distance of this, we know these can go pretty long, 4 feet, 5 meters, right? But when you get down to some of these other ones, 27 inches, 19 inches, right? This diffuse sensor, if you tried to apply it to this application, wouldn't see across this conveyor.
Sure.
Right. And then when we get to pallet conveyors that are 40, 50 inches long, we might find that this number exceeds the sensing distance of our normal photo eye and have to transition to something different. So that number is kind of typically not critical, but when it does become critical, it can really bite you. So we output that as well.
And so I'm wondering, we probably should show some sort of, and I don't want to digress too much on this, but we probably, should show some sort of detail in our drawings for the electrical direction.
Absolutely.
On what that is.
If we're doing the labor up front, we definitely want to make sure they're
I would say, if a minimum, if we showed the eye skewed and there was a 10-inch offset, we can increase that probably by 3 to 5 more inches just with the swivel in our bracket. But it's definitely something to think about, right?
Absolutely.
Yep. All right. So we're still talking about common uses, which we've talked about: jam and lane full, tracking eyes. Let's move on to some uncommon uses, and I'll just get us kicked off here. So we do overheight detection with photo eyes, and there's it's not going to sound Japanese, but there's a Japanese term for that called a poka-yoke, and it's really just like, I'm going to look it up. I forget exactly what poka-yoke stands for, but it's something like, I don't want to call it idiot proof, but that might actually be. Yeah, that's it. So poka-yoke is a Japanese term that means mistake proofing. And so
I like idiot proof.
Sometimes they're one and the same, right? The only difference is mistake, you're assumed to have forethought, and idiot proofing, there was just no thought. People are doing stuff without thinking, both of which occur in the warehouse a lot. And so overheight detection, I'm a fan. Like if you have a scan tunnel and the scan tunnel's low because it's got to read a barcode in an obscure position, and you have an open top container such as a tote or a box without the flaps down, and somebody sticks an umbrella in that thing. I mean, you say it won't happen, but it happens all the time.
Sounds like an Amazon warehouse.
Yeah, well, it sounds like a lot of warehouses.
A more common, not more common, but an application I've actually seen a fair amount of time is, this is somewhat not a perfect example because it's a side print and apply. But when you're doing an overhead print and apply, that's typically in like an 80-20 structure. So there's actually like a bar across the 80-20 structure holding the print and apply. So if you have the major flaps open on the case, it can hit that and rotate up and actually damage your head. So going into a print and apply, sometimes
absolutely,
you'll want to detect product is low enough to get through.
Absolutely, and like the scanner, you're scanning the front, the leading edge of the tote. That generally has a 80-20, like an aluminum extruded structure over top mounting that camera. And if you have an umbrella sticking out of a tote, it's going to smack the camera. It's going to damage the lens. Or at a minimum, I think it's funny, cartoonish way that the hook on the umbrella gets caught on that, and then it's just hanging there for every other tote to come by.
I prefer to catch the guy standing next to the conveyor and drag him down.
Like a vaudeville cane.
Amazon uses it quite often.
They're actually the first company that I saw use it. And here's the thing, right? We could debate that. We could have a whole other video debating the merits of train your people versus program it in. But that's the thing is Amazon, it's generally acceptable in their warehouses for, even though they say, oh, we train our operators not to do this, it happens a lot.
It does.
A lot.
Well, you have a lot of tech
and that's
labor.
why, it might cost $5,000 to fully design, engineer, program parts, and electrically install and commission a poka-yoke or an overheight sensor. But it probably, you let one umbrella smack into one camera, and now you're down $20,000 or $30,000. So it makes sense, but to an extent, like sometimes, and I said this could be a separate video, but I feel like we're permitting that kind of behavior by being like programming that kind of stuff in. And so But that's an uncommon use, but it's definitely something that we would do. And therefore, I would tell you that these brackets would be fine to use, but that's an application where I would want to see two pieces of extruded aluminum uprights on the side of the conveyor, mount our bracket to that, and so we want to give the customer the ability to slide it up and down, because just because they tell us, so we want 44 inches, that might change next week. They might want to lower it to 32 inches because somebody keeps putting something smaller than an umbrella in, but it's still getting caught up. So
one thing I wanted to mention was, and I have it kind of shown here, it's a laser diffused photo eye. So this photo eye actually is able to give you not only that the laser is blocked, but at what distance the laser is blocked. So you made me think about print.
So is that like a Ethernet IP or an analog signal?
So this one I think is I think this one was RS-485. I'm not sure on this one, but it's I think it's IO-Link.
Okay.
So IO-Link is just a communications protocol that allows you to get more than just discrete information from these sensors. But on print applies, quite often when you have a top apply, that tamp is coming down and slapping on the product. So you need to know the exact height of that product to make sure that the tamp is coming down to the right distance.
Sure.
So that's another over height detection that it would be.
Yeah, so actually the next thing that I was going to talk about for uncommon uses is width and length detection. And so
that one might actually just be like a set point, but I know they have a model that gives you an analog output, I think.
Yeah, it's pretty cool. And IFM, that's what this sensor is. I like them.
Yeah.
They are a really solid company that comes up with very inexpensive, direct to you, so not through a distributor, sensors. They're made in Germany, which we know the Germans are awesome when it comes to industrial automation. But this doesn't have the IO-Link stamp on it, but
that one might just be a set point.
Awesome.
But they definitely have a version that's like EIP and IO-Link.
Right. And so width and length detection, we can do, like you talk about a diffuse looking up, and we can actually use that for over width detection. Because imagine on a conveyor, you have 20 feet of skew rollers upstream. You're skewing a package to the right side rail. So you're pretty much guaranteed that all of your packages are going to be riding the right rail. And let's say your conveyor is 24 inches, but they say that we don't want anything wider than 20 inches on this conveyor. So you set the skew in there, and then you set your photo eye at like 20 and a half or 21 inches, diffuse looking up. And that's one way that you could do, that's a very inexpensive one way that you could do over width detection. And and get that. So like let's see here, practically with 4 sensors, you could do over height, over width, and over length detection. Because here, what Michael's showing you here is you have a diffuse looking up, and that package has been skewed to the right side of the conveyor for traveling from east to west. And if the package was wider, it would flag that sensor, and boom, we shut the conveyor down. We send off our alarm beacon. Somebody comes over, they take that package off the conveyor, they hit restart, and then it comes on down. And then we can actually use 2 standard polarized retroreflective eyes to do over length detection, which is what he's bringing in now, which is we would want to know when the leading edge of this package hits this photo eye. We then want to look at the trailing edge photo eye, and if it's blocked, package is too long. If it's not blocked, the package is deemed correct. So like I would say right now,
22 inches.
Right. So right now that package would be fine, because as the package traveling from right to left, leading edge triggers that photo eye. The rear photo eye is going to be clear, and it's going to let the package go. And also the diffuse looking up for over width detection. It's going to say, hey, the package is within specs lengthwise and widthwise. And then what we don't have shown is the overheight sensor. And we would also look at that. And if all of those conditions were good, the package is good, let it go through. And so that's a really inexpensive way to take care of this. The more expensive way would be something like, spending 150 grand and putting in a Cubiscan just to make sure that the package is within spec, right?
Yep.
And so, do you have any other thoughts on like uncommon uses of photo eyes? Like, you want to talk about gap detection and gap alarming by using 2 photo eyes? Like we just talked about length, but those 2 photo eyes can be used to detect gap too.
Yeah,
without tracking, right? Without an encoder.
Yeah, so really it would be a very similar kind of approach where we would have 2 sensors, and we put this one back to a standard polarized reflective 24-volt light-out photo eye. If you wanted to make sure that you always had a gap of, say 3 inches between each package, right?
Mm-hmm.
You're going to go ahead and put those 3 inches apart, and you would expect to never have them both blocked as packages are.
Can you bring a box in? So I want to talk about the coding aspect of this real quick. Because it's not just as easy as saying, hey, if these 2 photo eyes are blocked at the same time, that's an alarm. And that's a common misconception, because that's where we go first as a programmer is, oh, well, we should never have those 2 blocked. But that's actually not true, because what we'd have is, as the box comes across this from right to left,
sometimes you have a trigger on it.
Right? So we're going to block 1. That's not a problem. Then we're going to block the second one at the same time. That's also not a problem. That they're both blocked at the same time. And so as we get these packages moving across this conveyor, how we're going to program this is when that lagging eye sees not this leading one, keep going. So the lagging eye, keep going across, boom, right here, as that eye makes contact, a falling edge, we're then going to look instantly. Does the leading eye blocked? If it is, that's an alarm. Boxes are too close together. If it's not blocked, then the gap is good. And we repeat that process. But it's very tricky to make sure that you are programming it such that you're only monitoring on a falling edge of the trailing eye or the lagging eye. And so here we move the packages closer together. We're going to move them down the conveyor. Here both are blocked. The leading edge is clear, that's fine. And then we're continuing down. The second photo eye, keep going. That is clear right now. Boom, monitor. Oh, what? The leading edge is broken. That gap is too close. Pause the conveyor or kick both of those off. Or else let them go. You could have a recirc loop where the conveyor has a gapper, and for whatever reason, these guys may have been front to back.
And also in that situation, Rob, one thing that we've done in the past, especially on an MDR system like this, I know we're talking about photo eyes, but as soon as that second downstream photo eye got the trailing edge, we could pause this individual MDR for a moment and allow this one to pull.
Well, you can. That's like
a couple
dynamic
seconds
gapping,
of gap, right?
Absolutely.
Yep.
So
it pulls a couple seconds of gap, and you can even recheck it for what ends up being a few $100 compared to like
right down, right?
You recheck it again down here, and then you're not going to reject every gap error. You're going to try to fix it first, because now you say, hey, it's good.
Right. And so, let's just, before every sorter, there's generally a gapper. And so, but let's say that those packages came back to back, right? Front to back. And it only managed to pull a 2.5-inch gap. If we sent those on a recirc loop and then they came back and they hit that gapper again, likely it's going to fix the problem. But to what Michael's saying, when you have a dynamic gapper, we can teach the lagging conveyor to speed up 125% temporarily to pull that gap. And then maybe 10 feet down, you have another gap check, and it should be cleared. And if it's not cleared, then you can send them the jackpot, let them go to recirc, and then pull it again. Because every time you put the same 2 boxes on a gapper, it's just going to pull it apart more and more and more. So, Any other uncommon uses that you'd want to talk about photo eyes? Presence detection is the overarching thing, but what you do with that, I mean, it's just the possibilities are endless.
Yeah, I'd like to say that with our kind of latest revision of our add-on instructions, which, as you know, is just a kind of a pre-configured, pre-coded blocker we put in the PLCs, which allows our commissioning agents to not have to do as custom coding in the field, right? Which allows more efficient startups. But within that AOI, each photo eye is detecting position, and it has built-in jam detection. So every photo eye in our systems now are detecting for some sort of fault to prevent or mitigate product damage, downstream conveyor damage, premature jamming. So we're always monitoring positions a lot in the system. But one thing I want to point out with photo eyes that's not uncommon, but isn't kind of sensing product on the conveyor, but sensing things within the conveyor. For example, on a narrow belt sorter, there is a take-up on some of them that's tensioning all those narrow belts. Well, that take-up has a photo eye that's being blocked, and it's a diffuse photo eye. Sometimes you use proxies, but sometimes it's a photo eye. And if that take-up were to leave position, it's a fault for us to say there's a take-up error.
I mean, you could have the same thing.
Spirals.
Slack chain. Yeah, slack chain on the spiral.
Yep. Catenaries inside of shoe sorters have a photo eye that looks across, and if that photo eye gets broken, it's send and receive. So there's a lot of photo eyes that are using these systems that aren't just detecting product, but detecting the status of pieces of equipment.
Well, really, it's not really product detection as much as it's presence detection.
Yep, absolutely.
Right? And so one other, I'm not going to spend too much time on this, but head back down to that sorter.
Yep.
And so one thing that I learned, on those, so here we have 4 takeaway lanes on this sorter. And so very common, we want to just put a lane full eye here and call it a day. But if you ever have a round robin situation, right? Let's say that, and so we had this at Home Depot Crown Bolt. One of our sorters was just keeping empty boxes full on a conveyor. And we just simply put a lane full eye in, and later on realized on a round robin situation, if we do a 25 and a 50% and a 75% full, we can have so much better control in a round robin situation. For example, let's say that the round robin is set to do 3 cases. So 3 on 1, 3, 2, 3 on 3, 3 on 4, 3 on 1, and so forth. And what's happening is, let's say that today they're only, they have 2 packers on lane 1 and 1 packer on lane 2 and none on 3 and 4. You would expect them to disable lane 2 or lane 3 and lane 4, but you still have 2 packers on 1. So really the rate's twice as high. And what we do with that is, if it's 25% full, let's say lane 1 is 25% full and lane 2 is not full at all, we would still want to send 3 cases to lane 2, but we only now want to send 2 cases to lane 1 because they're getting balancing. Full, right? Yeah. That's load balancing. Then when we hit the 50% mark, we obviously know lane 2, they're not keeping up. So why would we send 3 cases to lane 2 when they can't even keep up? And lane 1 might be starved for product, right?
Absolutely.
So at 50%, we might say, hey, only send 1 case. So now we're still sending 3 cases to lane 1, and we're only sending 1 case to lane 2. And then when it gets to 75% full, we don't send any cases to lane 2. And now, it's just load balancing is another thing. So don't be afraid to put those photo eyes in 25, 50, and 75% full, especially in a round robin situation.
And even I would just kind of add to that a little bit, just even on a sorter, right? We have a recirculation line here, and if you notice, in the recirculation line, I have, and let me just talk about this for a moment. This symbol is also a photo eye symbol for us. You can see the symbol kind of inside this, kind of encapsulated within this geometry here. Electrically, it's still a photo eye for us, but we have a different signal indicating that we're going to use the photo eye that came pre-mounted on the conveyor. So PLC-wise and electrically, it's still a photo eye, but we have that separate symbol, which means, hey, electricians, you don't have to mount a physical eye here. And also, end user, you shouldn't be expecting to see a physical eye, even with our swivel mount brackets. So
noting that, first off, I'm saying you called it geometric. Would you call that an elongated hexagon that
Uh,
photo eye's inside,
2, 3.
or an elliptical hexagon?
I don't know what I would call it. You're the geometry guy.
No, I would call it. I was just thinking. I stopped listening to you as soon as you said it's a photo eye inside of a geometric box, and I started determining what it actually should be called. And I think it's an elongated hexagon, or it's an elliptical hexagon. So I don't know, but in the words of Michael Collins, I digress. Can you show? I know we've showed it all time, but just show the external photo eye symbol.
Yep. So if you look at them,
Yep.
I'm actually gonna.
Can you pull that off?
I'm gonna put them side by side here.
Yep. And then let's go through the iterations of them of what they would look like in CAD. And so, as Michael said, the internal photo eye, quote unquote internal, we're really just picking up the signal from like an MDR controller card.
If you see, it kind of looks the same.
Yeah. So it's really a photo eye within a geometrical box. On the internal, and the external has no. So that box is meant to represent like an MDR controller card or something like that. And we have different iterations of that. So if you go through, like, there's diffused, and I get that because the end is kind of like blown out, and then diffused looking up. So you see like it has no tail on it, so it's looking up at you. Through beam would be another one where you would probably see. So that's our standard. You should see that 99% of the time, and we're simulating the emitter on one end and the reflector on the other. And then there's through beam, so you can see an emitter on one side and a receiver or collector on the other side, right? And that's what the E and the R stand for, emitter and receiver. And there's what that ultrasonic.
Mm-hmm.
So ultrasonic. So that's the thing, ultrasonic. Sometimes we'd consider that a photo eye. We use it often in a warehouse to detect the presence of things like forklifts. So if a forklift is going to lower a pallet onto a conveyor, well, we just don't want to make sure that the pallet's on the conveyor, right? We need to make sure that the forklift is backed out before we start trying to take that pallet away.
Absolutely.
And so we would show that as a photo eye, but it's really more of like a proximity sensor.
Yep.
But for our intents and purposes, this is the symbol that it gets.
And I guess fundamentally, it's just the only real difference is instead of sending out and receiving light, it's sending out and receiving, I guess, what is it, radio waves?
Ultrasonic. It's actually, I think it's sending out a noise. Yeah.
Nice. I'm going to go yell at one, see if I can tell to make it come on.
Yeah, ultrasonic. So is that? So, yeah, because bats use ultrasonic.
And Aquaman.
Yes, and Aquaman. But I don't know how sound waves carry through water that well. So,
sonar.
Yeah, it is.
Yeah, it's really well.
Sonar. That's what I'm thinking about. And so
we got the ultrasonic.
Yep.
Sender, receiver. So through beam.
Yeah.
Standard. Diffuse looking.
And so the last thing we want to talk about, hopefully.
Well, I want to touch base on one thing first, which just to kind of bring it home what you were saying. Since this is a recirculation loop, meaning even if these downlanes all filled up, typically we wouldn't turn off this sorter. We would let product go through what we call recirculation.
Yep.
And in the event that there's recirculation, we're looking at this lane full condition. Anytime this lane full condition happens, it has a larger priority. So we're using that eye not only to detect that it's a lane full, but in our program.
Does it have higher priority?
It does,
I'm
because
going to question that real quick, because if your lanes are full and that's backing up, releasing more product in the conveyor, is that the answer?
So no. So we use this as a priority line to stop bringing in new product.
Got it. So let's assume that the down lanes are not full, because I want to talk about that next, because that's a different thing. The down lanes are not full. They can accept more product, and your recirc loop is getting full. Yes, we want to release in a priority mode to get that.
Because, like here I would have to set to say release 10 versus 4.
Right, because what happens when your recirc loop gets full?
Yeah, if I get up to this eye, and really in real life we actually ended up mounting this eye about down here. But so when I hit this eye, I'm pretty much going to switch. Instead of saying release 2 and 2 or 3 and 3, I might say release 10 and 2 to make sure that clears out. But if ever both got full, I would no longer induct any product. That way this can continue to flow around and around.
Right. And
even though nothing's diverted.
Let's that's an extreme. So that sensor right there, right? Go down. that guy right there, yes, he's a lane full sensor, but really that is truly an anti-gridlock sensor.
Yes.
And so the way it should be coded, at least in my mind, I'm sure this is open to interpretation, is if that anti-gridlock photo eye became blocked, I would release 0 product from the main line until the standard priority eye, so the first lane full eye, until that was cleared.
Yeah, yep. You let that
Right?
whole thing run.
I would let that whole thing go out. And so to do that, the down lanes would have to be open.
Yep.
Right?
Absolutely.
Because we don't look at that when we're releasing product on that 2-to-1 merge. We don't look to see, well, are the down lanes open? No. We just fire it in.
Yep.
And we don't actually look at that until we're on the sortation scanner before we do a lane assignment. So
any customer that's worked with a controls house that hasn't done this has probably cursed them out about 10 times when they're removing product from the freaking conveyor to allow it to start up again.
When we did Amazon Indy 8, we spent a full day and a half just in anti-gridlock programming and clearing automatically. It's a major, because think about it this way. You gridlock one sorter, the only solution is to dedicate one lane to where everything just gets dumped off on, and then you might as well not even have a sorter.
Yep.
You got to carry the product from one place to the other. Or you got to pause the conveyor, go over there by hand, and take them all off by hand, which is just as bad.
Yeah.
And so
it's a bad day for sure.
There is no reason to allow gridlock to happen. You put in an anti-gridlock lane full sensor, and then you put in your standard priority release sensor. If you get a gridlock, if your anti-gridlock is blocked, you release only that spur lane until your regular priority full is cleared.
Yep.
Right back down to 10 or fewer cases, or however it may be here.
And it's not the forum for this, I guess, but that's the one thing I love about our standard 2-to-1 merge block is that how easy that is to say, when this lane is full, let's say this backup eye is 1, 2, 3, 4, 5 back, and this one is also 5. We could easily say, hey, you're going to release 2 and 2, but as soon as you get full, switch to 5 and 5. Or in this case, since we have an such a sorter, we might say this same eye is 10. So release 2 and 2. If you get full, release 5. But if you get full, release 10. And that's so easy to change in our block. You can do it in a matter of seconds, which I really like about it.
It's also dynamic too. So you don't actually have to go into the program to change that. We can dynamically move out the 10 and move in a 25 to clear that gridlock. And there's just no excuse to have a sorter with a recirc lane and have it get into a gridlock pattern. I mean,
Absolutely.
that has to be. We could do a whole nother video just on anti-gridlock controls.
Agreed.
And how to clear that out properly.
Yep.
So we're getting long in the tooth here again. Last thing I want to talk about is NEMA ratings. We should do a whole video on what NEMA ratings are, but for the intent of this video, NEMA 12 is a standard rating for warehouses, which is really dust and coolant proof, or resistant, I should say, although you don't really have coolant problems in a warehouse. So for our intents and purposes, we're just going to say NEMA 12 is dust resistant. NEMA 4 is water resistant. And so and NEMA 1 is actually allows dust. So electrical installations are done in NEMA 1 fashion, right? Most photo eyes are actually like IP67, which is like the international rating for practically like NEMA 4, I think.
Yeah, the first number is dust, the second number is water, right?
Yes, and so I'm going to look those up right now.
No, because I'm looking at this SICK photo eye here while you're looking that up, and it struck me as odd that it has an enclosure type of type 1, but an IP rating of IP67, which I thought was kind of interesting.
Yep, so that's the first one. So like IP67, so 6 is dust tight. So 5 is dust protected, 6 is dust tight. To be honest with you, I've never actually even seen an IP rating lower than 6 something.
Yeah.
Right? I've never seen like a 40 or a 50.
Because one of them is just like big debris, like rocks won't fit in there or something.
So dust tight, and then the 7 is immersion up to 1 meter
for 1 minute.
And so So IP61 would be dripping water, so dust tightened dripping water. 63 is spraying water. 65 is water jet. 67 is immersion. So you can actually up to 3 feet immersed in the water. And then like there's you often hear IP69K. That's like wash down. Powerful jets of water spraying at it in a rotating fashion at 4 different angles, 2 minutes total, and you have to have 4 gallons a minute of water at 80 to 100 bar, which I think 15 psi is a bar. So pretty intense at water temperature of 176 degrees. I digress. We could do an enumerating video, and maybe one day we will. But
I hope not.
expect that our photo eyes are going to be much more resilient to the environment than you ever need. So
if they ever want to put a conveyor underwater, we're good.
Yeah, exactly. If your conveyor's underwater, we're still good as long as the photo eyes. Now, the electrical installations that we do, and it's common in the industry, is NEMA 1, and that really is just keeping items out of that and keeping humans safe. Dust can still... the dust generally does not accumulate in there, although it's not dust tight. But it's definitely not watertight and stuff like that. But that's pretty much it. Do you have anything in closing?
No, that's
Michael?
it. There's some obscure photo eyes out there, but in our industry, I think we pretty much covered the majority of things anybody might want to know about. But I would just say that if you're watching this video and a question or a comment comes up, then I would love to hop back on or even have a conversation. We could bring somebody else in to talk about what somebody might have a question about.
I did enjoy doing this, and in the future, there's an opportunity where we might invite some lucky people on the air here with us to talk about things. If they lend some industry knowledge. So, if we ever did a video on a particular item that somebody is, very interested in, we might invite that particular person on here. So if we were ever doing a video on elk hunting, we might invite James on here.
Yeah.
But if we were doing a video on programming, we might invite Cy or somebody who really knows what they're doing.
Like an actual programmer.
Yeah, like an actual coder.
Yeah.
So I had a good time doing it, and I'm looking forward to the next one. So
Absolutely.
Let us know what you think about the video, and I commend you if you made it all the way through, because I'm watching the ticker right now, and I think the first part 1 was 40 minutes and part 2 is 57 minutes, which is ridiculous because I actually thought it was going to be like 30 or under.
Yeah, so you were like, hey, let's make a part 2 that's a half
I
hour
actually
long.
think I told my wife that this is only going to take a half an hour to shoot the whole video, so I'll be home in no time. And then here we are, 2 hours of video, and that didn't include prep time or getting set up.
This happens to us on the phone while we're driving home too.
Yeah,
Hey, you got a minute?
In fact, I will tell you that this was a brainchild of ours. Every time I drive back from a particular store in Pennsylvania, Michael and I call each other out of the blue, and we just come up with these take over the world harebrained schemes, and it's just starting here and allowing new people at Pendant to really get immersed in the technical stuff, and then even hoping that one day we can share these videos with our integrators and, increase their technical capabilities and knowledge so that when we discuss things, they're wise like us and they can go identify issues. And let's just be honest, right? This little bit of knowledge helps all salespeople in our entire industry, from integrators to controls people, be able to serve the customer better and sell a better product and deliver a better product at the end of the day, right?
Absolutely.
All right, so that's it for me signing off on episode 1, part 2 of a 1-part video.
Yep.
It's Rob and Michael.
See you guys.
See ya.